Dear respected faculties, Assalamu alaikum. I am MARZAN and my ID is 191011651. So today I'll be explaining how to make a robot in Webots. We know there are a lot of kind of robots which has sensors with them and which can detect objects. So one of this kind of robot is an object recognition robot. Also, so we have made one object recognition robot. So let's just explore how to make this robot. So to do that, first we'll go to this class sign, and then from the base node we'll just add the robot node, and after that we'll have a children's section in the robot node, and here we'll create multiple child nodes. Also, first we'll create the body, so we'll go for the body first. So we add shape in the children node of the robot, and then we'll have this appearance and geometry. So in the geometry I have added box, so to give it the boxy shape, and I have given the size as 0.1 and 0.05 and 0.2 so that it be like a rectangular shape. One thing to mention here is that the front part is the front part of the robot is the z-axis, top part is y-axis, and left part is the positive x-axis. So now another thing here is that I have named this shape as body so that I can use it to define the bounding object of the robot node, which actually refers to the collision. And also I have added physics here, so our robot can move around like it would in real life. It actually refers to friction. When we're done with this one, we'll move to the wheels section. So for that, we'll just go to the plus sign, and from the base node we'll add the hinge joint, and from the hinge joint we will add the joint parameters, and we'll add a rotational motor in device, and we'll just name this one as wheel 1, and we'll add solid in the endpoint. We'll just go to the children section of the endpoint, and we'll add shape and name it as well for the collision. And also in the geometry I have added cylinder, given it a height of 0.02 and a radius of 0.04, and made the subdivision to 24. And also here I have given the PBR appearance and made the color to red. Also I have decreased the metalness. Another thing is that I have done the same in the body of the robot, that is I had given it PBR appearance, made the color to blue, and decreased the metalness to 0. So we're done with our wheel 1, but we have to make the translation to 0.06, 0, and 0.05. This is because we want to define the relative gap between the body and the wheel. And after that, we'll just change the rotation to 0, 0, 1, and angle to 1.5708. It can be seen here. This is because I've already simulated this robot, and that is why the axis and the angle has changed. But if we didn't change the angle to 1.5708, that is to 90 degree, our wheels would be flat and would be along with this floor. So when we're done with this translation, we'll just copy the translation and paste it in the anchor. This is a must. Our anchor has to be exactly as same as the translation of the endpoint. So when we're done with this, we'll just copy this and we'll paste it 3 times, and we'll just change the name of the device. We'll change them to wheel 3 and wheel 3, wheel 4, wheel 2, and also we'll just change the translation according to the location of the wheel, and copy the translation and paste it in the anchor. So when we're done with the 4 wheels, we'll just we're left to do with the distance sensor and the camera sensor. So to do that, you can see here first, let me show you that I have added two distance sensor here. One is covering the right side, another one is covering the left side. So we'll just go to this children section of the robot, and we'll go to the plus sign, and from the base we'll add distance sensor. So for the first distance sensor, we name it to DS right, and then we add a shape in the children section and name it as DS2, so that we can add collision and add physics. And also I have changed the PBR appearance to and also I've added the color to maroon, decreased metalness to 0, and given it a boxy shape, and gave them a size of 0.01 in all of these sides. We are done with our right side's distance sensor. We'll just copy all. Oh, also, I have given the translation to 0.02 in x-axis, 0 in y-axis, 0.1 in z-axis, and rotation to 0, -1, 0, and angle to 1.27. We'll just copy this one and then paste it, and we'll just change the name to DS left, and we'll change the translation to -0.02 and rotation angle to 1.87. Now for the camera, I have given a pole. So for that, I have taken a solid from the base nodes and named it as camera stand. And in the children section, I have taken shape, and in the geometry, I have given box and gave it a size of 0.03 in x and z axis and 0.25 in y axis. So because of this, I have this pole-like structure, and also I have given it the red color and metalness to 0, and we'll then just click on the shape and go to this plus sign, and from the base node, we'll add the camera. And in the camera, I have named it as cam, and changed the translation to 0.001, 0.1, and 0. and rotation to 010 and angle to minus 2.88. This is because if I had not done this, then our camera would be pointing backwards. So we're done with making our robot and adding these sensors. So also another thing is that I have added some obstacles here beforehand. So I have taken some solid nodes and given the desired shapes, and here you can see that I have taken a sphere, I have taken two cylinders, I have taken a cone and a capsule. I have given them names, so I have given them collisions, you can see it here. And for the cone, I have given two bounding objects because it just doesn't have its own bounding object. Also, I have turned on their recognition color, you can see it here, so that our camera can detect them. So let's just simulate this one and check our robot can detect objects or not. Here you can see it is detecting the objects and taking them into a frame. It is fitting them into a frame, and it rotated itself when it detected an object. So this was all about my part, and the other parts will be described by my friends. So thank you everyone. Stay safe and stay well. Assalamu alaikum.
Assalamu alaikum. I am Tanvir NAFIS, ID 191015575. I am going to explain the sensor part of our project. So first, from the children directory of our system, we have taken the sensors from the base nodes. We have mainly used here the camera sensor and the distance sensor. The distance sensor is to measure the distance from the object, and the camera sensor is to detect the object. So we have set the camera sensor on solid, and then we have added the shape node in children, and we have taken appear appearance and geometry box to give it a shape. We have also added the suitable colors for the appearance purposes, and then we went to the translation part, and we have manipulated the xyz coordinate, and in the rotation part we have set an angle. And then coming to the distance sensor, we have manipulated the xyz coordinate of the translation also, and we have set an angle in rotation also. And then we have added the collision from bounding object, and we have also added physics, density and mass, so that the objects can have physical properties, and we can see that our project is running well. So that's all from my side. Thank you.
Assalamualaikum. This is TAJRIN PRARTHONA 191013997. Firstly, we have made the anchor values equal to the translation values of the wheel in the robot section because anchor values define the axis of rotation and it should be equal to translation values. And in the viewpoint, as you can see in the viewpoint, we set the field of views 0.785 and height and width of camera 64 so that it can take high resolution picture. After that, in the controller code, I take this controller code from the Webots library and set the name to controller. Then I have selected this controller code. Here is a code for camera. It is called the camera pointer code. This line enables the camera with time step 64, and it will send beta after every 64 milliseconds, and it will recognize also after every 64 milliseconds. This is the code for motor wheels, and I set the wheel names as wheel 1, wheel 2, and wheel 3 according to the hinge plan part. And in the library section, here to make the obstacle sphere to cylinders, cone, and capsule, we take the solid nodes and then given collision to them. And the collision is basically here work as a detection primitive when placed in a bounding object. And the capsule is particularly fast and accurate collision detection primitive. And also in the geometry section, also in the geometry center, we set the bottom true, high 0.3, radius 0.1, side true, top true, subdivision 24. And we give appearance PBR and take the big size, mentioning that if we use physics here, the ball can be turned one side to another, but we don't use physics here. And also we use recognition colors in the every children section so that it can easily detect the color of the object. And that's all from me. Forget to mention that every member of our group tried to explain the obstacle behind their individual part. Thank you.
This is ASIF and I am going to overview of our project. This is our project. This is the project component part from where we added different kind of components to the project, like different parts of the robot and object which has to detect by the robot. And this is our code part which is written in C++, where we added those components to run the project successfully. In this project, those are the obstacles which has to detect by the this robot has distance sensor in its front. Through this distance sensor, the robot can easily detect those objects and barriers and change its direction. In the camera part, we can easily see how this robot detecting these objects and changing its direction. So how this robot is working and changing its direction.